Okay, so today's notes are about gravity in space. This is page 9 on the back of the last set of notes seasons. This is page 9. You're going to look for the essential question: what determines the strength and force of gravity between two objects? What two factors combine to keep the moon and Earth in orbit? What is the difference between mass and weight? All right, you're going to look for that. Put gravity in space up at the top. Page 9, put the date on there. We're going to hop to the anticipation guide. Number 5 and 6, you're going to write on the left-hand side, which is before. Gravity depends on two factors: the masses of the object and the distance between them. True or false? Gravity is pulling you towards the Earth, but you are also pulling the Earth towards you. True or false? All right. Let's take a look at gravity. What the heck is gravity? To start, gravity attracts all objects towards each other. Isaac Newton, he didn't discover gravity. He was the first to realize gravity occurs everywhere. The force of gravity holds Earth and the moon together. That's why we're looking at it. That's me right there. So, the laws of universal gravitation. Newton, like we said, he didn't discover it. He just realized it's going on everywhere. His law of the universal gravitation states that every object in the universe attracts every other object in the universe. This means gravity pulls you towards Earth, but you are also pulling the Earth towards you. So not only is the Earth pulling the apple down, the apple is pulling the Earth towards itself up. All right? And gravity is a force. So gravity's strength of force between two objects, it depends on the couple factors. First is the mass of the object, and then you have the distance. Gravity attracts objects towards one another. So if I have a bigger mass, for instance, I'm going to use my little metal magnet balls. The mass of this, there's more mass to this than there is to this tiny one. This has a more force of gravity than this at the same distance. But say I increase the distance and I go up here as opposed to down here. If the distance increases like this did, the force decreases, that gravity decreases the force of it on gravity. So, like, if you think in space, two objects, if they, you have 4 different sets of objects. 2 of the objects are very tiny, and they're about this far away from each other. They have a good gravity, force of gravity. But the bigger ones, if they're like this, they have more gravity towards each other. And this comes into effect when you're thinking of the Earth and the moon versus the Earth and the sun. What do I mean by that? So, like, have the Earth and the moon. I know this is not the size of the moon, but they have a good gravity towards each other. They have quite a bit of gravity. And then you have the sun and the Earth. The sun will have more gravity towards the Earth, but the more distance you have, which we're farther away from the sun than the moon, the less gravity pulls, if that makes sense. All right? So gravity depends on mass and distance. The more mass you have, the more gravity you have, if you have the same distance. All right? And this is going to come into effect with the moon and the Earth and the sun. The sun is, by the way, the sun is massive, and the Earth is more massive than the moon. But the sun and the Earth have more distance, so the gravity isn't as great, whereas the distance between the Earth and the moon is less, so there's more gravitation. That's where we get those tides. Remember what tides bring? Tidal waves, because of how close the moon is to the earth and the pull of the gravity from the moon and the earth on the earth and the earth on the moon. And then you have this thing called air resistance. So air resistance is the opposite force acting against gravity. So when you saw the apple falling from the tree, that clunked Newton on the head. It clunked him on the head because gravity is pulling down. But you have air resistance pushing back up on it. Okay? Now we have the term mass. So mass is not the same thing as weight. Mass does not change when an object's location in a space changes. Remember, mass is like the amount of you there is, right? The amount of you is not going to change if you go from Earth to the moon, like this astronaut. The mass, they have 120 kilograms. That mass doesn't change when they go to the moon. However, gravity changes, which means the weight changes. So weight is the force of gravity on that object. The mass of you, how much there is of you getting pulled down, causes weight, which fluctuates throughout the day, throughout where you are on the earth, because the earth is not a perfect circle. All right, so comparing mass and weight. Unlike mass, which does not change, I've stated this, an object's weight can change depending on location. For example, a person who weighs 120 pounds on Earth would weigh 20 pounds on the moon. It's because the force of gravity on the moon is 1/6 of the Earth, of that than the Earth. So it'd be 120 divided by 6. It means you'd only weigh 20 pounds. And as you can see, like I just wanted to show a really neat comparison. To find your weight, multiply your weight on Earth, pounds or kilograms, by the ratio of the planet to the Earth's gravity. Example, multiply by 0.91 for Venus or 2.34 for Jupiter. So Jupiter, man, it would be incredibly hard to lift your hand on Jupiter because you're 2.34 times as heavy on Jupiter, whereas on Venus it'd be a little bit easier because you don't have as much on you. All right, so here's some fun facts. The moon is about 1/4 the size of the Earth. So here is our moon. Oh, where is our moon? There's our moon right there, Earth's moon, which is comparable to Io, one of Jupiter's moon. Europa's a little bit smaller, but then you have Ganymede, which is much bigger, and Callisto. Mars's moons, Phobos and Deimos, are much smaller than the moon, our moon. And then you can see Saturn's moons, Uranus's moons, Neptune's, and although it says Pluto, Pluto is no longer considered a planet, but more a planetoid. I think they found that Charon and Pluto kind of like orbit each other a little bit. All right, quiz time. This is quiz 3. Put gravity, quiz 3. 1, 2, 3, 4, 5. So gravity depends on what two things? Is it mass and distance, air resistance and pressure, density and air resistance, rotation and time? Mass and distance. An object, what can change depending on its motion? Is it mass, weight, density, or volume? Its weight can change, not its mass. The force opposite to gravity is called what? Is it inertia, air resistance, friction, or velocity? It's going to be air resistance. What does not change when an object's location in space changes? Its weight, its work, its mass, or its power? This one's going to be mass. What is the pulling force that attracts two objects? Is it the magnetic field, the mass, the weight, or the gravity? It's going to be gravity. All right, let's flop back to the anticipation guide and look at number 5. Gravity depends on two factors: the masses of the object and the distance between them. True or false? It's true. As the distance increases, the force of gravity decreases. Gravity is pulling you towards the earth, but you are also pulling the earth towards you. True or false? This is also true. All matter has gravity, including you. All right, let's go back to the notes, go to summary. What determines the strength and force of gravity between two objects? Remember, there are two things. Gravity's strength and force between two objects depends on its mass and its distance. The more mass, the more gravity. The more there's distance, the less gravity you have. What two factors combine to keep the moon and Earth in orbit? The Earth and moon keep in orbit by mass. Because the Earth has more mass than the moon, it's keeping it in orbit. And distance, they don't have that much of a distance comparable to the sun. What is the difference between mass and weight? Mass is the amount of you there is, and weight is how much gravity is pulling on you. All right, that is it. If you have any questions, please don't hesitate to ask, and I hope you guys have a great day.